Okay. It is week 2 and it's Wednesday and we had a holiday on Monday and then we have a holiday this coming Monday as well. So kind of a lot of holidays for us, but I guess that's okay. We'll just try to compress everything and get everything to fit in. So yeah. I got my voice is a little bit gravelly today. I apologize for that. This is just how I'm going to sound. So homework 2 has been posted, and in homework 2, you're going to kind of create. There's a couple parts. One is you're going to create a board for the game Chutes and Ladders, and there's things involved with that. And then you'll also simulate playing the game Chutes and Ladders. And so a lot of times it can feel overwhelming when you read through the instructions and you're not quite sure how to start. So I wanted to just give you a few tips as far as getting started with homework 2, as far as getting the board going and then filling in everything from there. So I don't know if you guys have taken a look at it. I hope you've at least downloaded the file and taken a look at what you're supposed to do. But one of the first tasks is to draw the game board. And what we want to do is we want to kind of keep the code flexible. That's going to allow us to draw different sized boards. So the base game board is 10 by 10, but then we can make, other sized boards, 6 by 7 and things like that. All right. And so, what I recommend is just start by working in the global environment. Don't immediately start writing a function, but just start by working in the global environment and see if you can kind of produce, something that looks like what you're going for. And then if you're able to do that, then you can try encapsulating those lines of code into a function. So first I'm going to just start by kind of clearing the entire environment and then just creating a blank plot. So plot.new creates a blank plot. There's absolutely nothing to show for it right now. Okay. And then what we can do is we can add segments to the plot. All right. So we can use the tool segment and the segments function. This is all using base R's kind of graphics capabilities. You plug in basically a starting X and an ending X point. You have X0 and X1 and Y0 and Y1. And we have a 10 by 10 board. So I'm going to just go from 0 to 10. So I'm going to go 0, 0 to 10, 10. And this draws kind of a diagonal line. But what I want is, I don't want diagonal lines. I want horizontal lines and I want vertical lines. So I'm going to start by trying to go from 0, 0 to 10, 0. And that's what I have here. X is 0, Y is 0, X1 is 10, and Y1 is 0. And that's going to draw a horizontal line. And then let's say I want to draw another line above that. I can draw a second segment, this one with Y equal to 1. So the starting Y is 1 and the ending Y is 1. So this is 0, 0. This is 10, 0. This is 0, 1. And this is 10, 1. Okay. And if I try to draw a third line, it gets a little, you can't actually see it because it draws this one and then it draws this one. And then at 0, 2, it's up here, but it doesn't actually show. So in order to kind of get everything to fit, I can use the function plot window, right? So this is just kind of me working through getting things to show. So here, when I create a new plot, I'm going to set the limits of my plot. Okay, I'm going to set the X limits to go from 0 to 10, the Y limits to go from 0 to 10, and then aspect ratio 1 means keep the X and Y aspect ratio equal to each other so that squares look like squares, circles look like circles rather than looking like rectangles. All right, and so just those 3 same commands before, this draws the first plot going from 0, 0 to 10, 0. This one goes from 0, 1 to 10, 1, and this one goes from 0, 2 to 10, 2, right? So these are the segments. And so what I can do now is I can kind of create a loop to go from 0 through 10, and rather than plotting what I'm going to do is I'm going to replace the y coordinate, which started off at 0 and then goes to 1 and then goes to 2. I'm going to replace that with the variable r to kind of represent what row I'm in, right? So I start off at 0, 0, and then row 1, row 2, row 3, all the way up to row 10. So now I have 10 horizontal lines. Okay. Is this okay with everybody? Just how I'm drawing a whole bunch of grid lines here. And then now I want to do vertical lines, and I'll basically do the same thing. Okay. For the vertical lines, I'm going to have another loop here where for C represents column, and we're going to start off at 0, and then I'll do it for 1 and all the way up through 10. And this time the part that is, we'll start with y equal to 0 and y1 equal to 10. Okay. And so this will draw a 10 by 10 grid, which serves as a kind of a starting point as far as drawing the chutes and ladders board goes. Okay. All right. What is the C? So C is a variable, right? And it's going to vary within this loop, this for loop. It starts off at 0 and goes through 10. So the first iteration C is 0, the next iteration C is 1, and it goes all the way until C is 10. Okay, so this one will do all of the horizontal row lines, and then this one will do all of the vertical lines. Okay. And again, so far everything here, I've just been kind of working in the global environment. And then, once I get comfortable with this, then I could say, all right, what, maybe I can try making a function, right, where I'm going to be able to specify how many rows of how many grid rows I want and how many grid columns I want. Okay. And then we could replace, rather than 10, we'll specify some other number. Okay. Right. Some kind of variable there. Okay. And I think this can act as kind of a good starting spot as far as homework 2 goes. And then as you, other things you'll need to do is you'll need to add numbers. So you need to go 1 through 10, and then 11, 12, 13, 11 through 20 goes this way. And then 21 through 30 goes this way, so on and so forth, until you get to 100 up there. And, you kind of have to figure out, how am I going to place text? And so there's different functions, right? So what you're going to do is you're going to just kind of continue building up the code, like adding code to place the text values, and then you'll add code to kind of add arrows to represent the chutes and the ladders. And, each time I recommend that you kind of clear your environment, just because as you're working in the global environment, it's often easy to kind of create variables that you think, are there and readily available, but they're not. So just be mindful of that, right? So here I wrote, one potential source of problems is that the number of rows and the number of columns is both 10 as far as this board goes, and it can be confusing, when you turn your code into a function where you want like the number of rows and the number of columns to be variables, right? And it could be helpful if you set the number of rows equal to 9 and the number of columns equal to 10 or something, in order to kind of differentiate these values. And then when it's time to kind of create functions and variables, you can kind of find, any instance of 9, that's supposed to be the number of rows, and any instance of 10 is supposed to be the number of columns. So, so that's something to think about. Okay. Have any of you guys started working on homework 2 and tried figuring some of this out? Okay, well, great. All right, so it's good to see some of you guys nodding your head. And yeah, the homework exercises are meant to be a little bit of a challenge. They're not meant to be super easy, but they're also not meant to be overwhelmingly difficult. And I think you already have learned everything you need to learn as far as working on homework 2. So you should be able to complete homework 2 without any of the stuff I cover in today's lecture. So the stuff I cover in today's lecture will be more relevant for homework 3, which will, be assigned, this coming Monday. So I know it's summer class and everything just kind of, it's like one thing right after another. So, so I hope that's all right. Okay. Hopefully these, you get a couple long weekends where I hope you guys are able to just breathe a little bit. Okay, so I want to talk about importing and exporting data. So, you got some basic commands here. Let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter D. D as in dog. D as in dog. Okay. Yes, so there's a question about the midterm exam, and I believe I have the midterm exam next week. It's going to be a take-home exam, and yes, you can expect the stuff I cover in today's lecture to at least some of it to make an appearance in the midterm exam. So, okay. All right, so reading in stuff. We've got readline, read.table, read.csv. I think they've changed this behavior. Strings as factors equals false. I think this has been updated so that this is the default, is that strings as factors equals false. Okay. Is the take-home exam timed? Yeah, we'll discuss how the I'm still working on the take-home exam, so give me I'll talk about it next week. Okay. There's a few details I'm working on. There's a bunch of other packages that are part of the tidyverse, and we'll talk about the tidyverse in a moment here. But these are great for reading just general files and other files. So if you need to read in Excel files, you can read in Excel. If you have data from some other program like SAS, SPSS, or Stata, you can use Haven. There's another package called data.table that's not part of the tidyverse, but it handles very large data sets. Okay, and then readr is part of the tidyverse, and it's used for just your general text files like CSVs, TXT files, and the like. Okay. And so if you look at read package readr, it's got a whole bunch of these things: read CSV, read TSV, read delim, read FWF for fixed width files, and things of that nature. And it will kind of read everything into your data set. So that's handy. So these are just kind of a list of things that are useful and good to know. The package data.table has a function fread, and that acts a lot kind of like read_CSV, but fread is designed for fastest performance. So if you have a very large data file, say something that's over 1 gigabyte, I would recommend fread. Okay, and the best source of information about how to use data.table and everything there is going to be the official documentation, which is available here. So what's the difference between read_CSV and fread? And this is, I've taken this directly from the readr website, and they're both very similar, whereas fread is faster than read_CSV. Read_CSV has a slightly more sophisticated parser, which will recognize kind of double and backslash escapes, and they can produce factors and date times directly. Read_CSV will ask you to supply the parameters, whereas fread will kind of automatically guess your delimiters as far as these text files go. And so readr is designed to be quite general, whereas fread is designed to be as fast as possible. So read_CSV works pretty well in most circumstances. But again, if you have a very large data set, maybe from like, something over 1 gigabyte big, or, if you're in, say, data fest and you have this large data set, fread can be handy in those circumstances. If you want to read in something from Excel, you can use read Excel, and the file is read_Excel. And the default will just read in the first worksheet, and you can specify other worksheets by specifying either the name or the sheet number, because Excel handles multiple spreadsheets multiple worksheets stored within one file. There's also another package called Downloader, and this will allow you to kind of download files from the internet, which is handy, right? So there's a function called download.file, and this used to work great, but now pretty much everything on the internet is locked behind a secure website, HTTPS, and so this doesn't work anymore. So this doesn't know how to handle secure websites. So use library downloader, and then you have some website of something that you want to download from. So this is just coming from GitHub. I got the iris.csv file on GitHub, and you can just do download URL, and then you give it the name of the file where you want to save it. And then once you have it saved there, you can then read it in. So you can read in this CSV file into, say, some data set, some object inside of R. Okay. Sometimes you need to save objects into files so that you can reference and use them later. Right. So one thing you can do is you can just do save, and then you have the name of your objects, right? So inside of R, you go into your environment, and you might have different objects in here. You just basically give the name of the objects in there, and you put those in there, and then you name the file where you want to save it, right? So it's going to store this as .r data file. So we're going to call this, objects.r data or whatever you want. Okay. You can also take some vector matrix or some kind of object and do write, and you can say write, file.txt. And so actually, yeah, this is best for some kind of atomic vector, right? And it will save the atomic vector as plain text. Okay. If you have a data frame, you can write to a CSV file. So you can do write.csv, the data frame, and the file name, right? By default, saving a data frame is going to save the row names. And if you don't like that behavior, do row names equals false. That will remove the row names. Okay. I think that's okay. This is mostly here for your reference in case you're like, oh, how do I write files, and how do I save files, and how do I load files? You can kind of just refer back to these things. There's another package called Lubridate, and this makes handling date and time information in R much, much, much easier. So handling date and time information with base R can be frustrating and painful, and Lubridate just makes this a lot easier. So you can do this by, let me just kind of show you what it looks like if you don't use Lubridate. So R's date function is as.date, and this will kind of convert strings into dates. And so you have to say, all right, here's my string, January 15th, 1999. And this is in the format %B, capital B for January, %d for the date, the day, and capital Y for a 4-digit year. And then there's a comma after here. And it has to, this format string has to match perfectly, otherwise it gets confused. And if you have it matching perfectly, then it goes, oh yeah, that's 1999-01-15. If you forget the comma, right? If you forget this comma right here, and you say, all right, turn this thing into a date, the as.date function gets confused and says, I don't know what this is, okay? If you have another date in this format, 12/15/2001, and you say, you can say, this is in %M, %D, M for numeric month, whereas %B is for the month written out in English. Okay. And you need to have the dashes here, and it will say, okay, I recognize that. But if you leave out the dashes, or if the formatting is off, it says, I don't know what that is. Okay. And so it can get very, very, very tedious and very frustrating trying to figure out, why am I still getting NAs when you're going through kind of a column of dates, and there's slightly different formats between how people have specified written, if you have some kind of form where it says, enter your birthday, and some people, put dashes, and some people don't put dashes, and things like that. It can lead to all kinds of problems. Okay. So just here's another example. Here I've got 3 dates: January 15th, 99, just 12-15/2001, 03/18/2002. And you can only have one format string. And so here I have this format string, and it works for this one, but it doesn't work for the other two. So I get this one gets turned into a date, and these don't work. Here, if I have this format string, which works for the middle one, but not for the first and last one. And then the last one, I've got this format string, which has slashes, and that works for this one, but not for the other two, right? So this is frustrating if you've got different things here, okay? With Lubridate, all you have to do is you take the same string of dates here, January 15th, 99, 12/15/2001, 03/18/2002. You can just say, all of these are in the form month, day, year. And then Lubridate goes through and says, oh yeah, I figured this out, I figured this out, and I figured this out. And it turns all of them into a date object by recognizing that all of these things are in the form month, day, and year. Okay, so this is much, much, much easier. The only thing that this requires is that it requires that the information be in the form month, day, year. Okay, and then it works. Okay, so Lubridate just makes handling date information much easier in R, and I strongly recommend it anytime you're going to be handling dates. Okay. So here, if you have something like this, 03, 04, 05, you do have to, this is ambiguous, right? Is this in year, month, day? Is this month, day, year, day, month, year, right? All of these things, it's quite ambiguous. So you do have to specify what this is, right? So if this is year, then it would go 2003, April 5th. If this is month, day, year, then this would be March 4th, 2005. And if this is day, month, year, like if we were in Europe, this would be 2005, April 3rd. Okay. And then if you try to do something like this, month, day, year, right, where 25 is the month and the D is 12, it's going to say, that doesn't quite work, right? And then it'll give you an NA because you're trying to do a month, day, year where you're trying to ask for the 25th month. Okay, so Lubridate is pretty good. You just have to kind of specify what order the things are in order for it to work. Otherwise, just because it doesn't want to make assumptions for you, right? Because this is ambiguous. Okay, another useful package is the library rvest. Okay, rvest is for like harvesting or scraping things off of the web. Okay, and in order to use rvest, we have to use what's known as the Selector Gadget. Let me just go to Selector Gadget. All right, so this is what Selector Gadget looks like if you go to the Selector Gadget website. And what you have to do is, all you have to do is you just drag this link to your bookmarks bar. Okay, and I've already have this dragged to my bookmarks bar here where I've got Selector Gadget. And you can also watch kind of this video on how Selector Gadget works. And what this will do is it does what rvest is good at is it's great for fairly static web pages with well-defined HTML tags. It doesn't work super great where sites are generated via JavaScript. For example, sites that have like infinite scroll, it doesn't quite work well there. And it also doesn't work well if it's a site where you have to be logged in to view content, say like Facebook or something like that. So if in order to view anything on Facebook, you've got to be logged in, and it's not going to work well for sites like that. Okay, so a very brief understanding of HTML can be helpful. So if we were to go to some, let me go to here. Let me go to pull up a blank thing. So if you go to Reddit, this is kind of what it looks like, and you can look at the source, and this is this is basically how the web page is written. And basically your web browser reads through all of this stuff, and it says, okay, based on this information here, this is how I'm supposed to format and display the content here. Okay, pretty much all of these things are the formatting is held consistently by using these little class tags. These are CSS tags. So it says post, sharing button, et cetera, et cetera, et cetera. Okay, so it's a whole bunch of stuff here. And so anyway, there's HTML, that's the markup language, and you apply these different little CSS tags that kind of tell the browser what the function of these links and this text is. And it also tells the browser how to kind of format them, right? And so when you look at these things, the formatting is held kind of consistent by using these CSS tags, okay? And so if you were to kind of look at the content, you might see something like this, right? You might see class first, class share button, class save button, class hide button, class report button, things like that. And there's like different things in there, okay? And this is what some HTML might look like. And what Selector Gadget does is it looks at those CSS tags, and it basically selects all the tags on the web page that has a specific tag. So if we go to the site and click on the text that we want to capture, Selector Gadget highlights everything, and it will kind of capture it in yellow here. So let me see if I can do this. All right. So I'm going to go ahead and close this out. I'm going to click Selector Gadget. And when I do this, so all right, so here we're going to start off at Reddit here. And I'm going to click the, remember I dragged the Selector Gadget widget to the toolbar. So if you go to Selector Gadget, okay, what you have to do is it says drag this link to your bookmark bar, right? So you're going to just drag this, put it in your bookmark bar. So I've already done that. I've got Selector Gadget in my bookmark bar. And then now that I'm on the website, let's say I want to kind of extract the number of comments on the website, right? So this number of comments, 1,407. So are you guys able to see this? Let me zoom in a little bit more here. So I'm going to click Selector Gadget. And when I do that, this thing down here pops up. And now wherever I hover, it shows me, it highlights stuff in orange, right? It puts an orange thing around the box, and it kind of shows the little tags that show up. So here I'm going to click this. This is the bit of information I want to pull out. So I'm going to click this, and now this thing has turned green, and a whole bunch of other stuff has turned yellow. Now, really, I only want the number of comments. So I'm going to click stuff that I don't want. I don't want this part, which is in yellow. So when I hover over it, it shows up in red. I'm going to go ahead and click that, and that turns it off. And now all the things that it's going to extract show up in yellow, and it tells me that the tag that I'm going to extract is going to be .comments. And that sounds like what I want. So I'm going to highlight this, hit Control-C on my keyboard, and use that to copy. Okay. And so, oops. So on with rvest, so if I select this tag .comments, okay, then the selector gadget will identify all the text that's surrounded with the class .comments. All right. And then in rvest, what I'm going to do is I'm going to give the instructions. I'm going to say read the HTML page from old.reddit.com. Okay. And when I do that, what I want to do is I want to extract out all of the HTML nodes that are identified with the tag .comments. Okay. So I'm using kind of tidyverse notation here. So we're going to start off with old Reddit. I'm going to pipe this. This is telling me take the contents of old Reddit, pipe it into the function which says extract all of the nodes that have this particular tag .comments. Okay, and then from there extract out the text associated with those nodes. Okay, so I could do that right now. Zoom in a little bit here. So let's do library rvest. Okay, and we're gonna read HTML. So we're gonna just call this read _HTML. Give the web address. Okay. All right. So it reads it in, and if I say, well, what is old Reddit? Okay, it tells me it's this HTML document. So what I want to do is from there, I want to have it read the HTML nodes. Again, the tag that I'm going to identify is the .comments, which I got from doing this, right? Maybe let's see if I can get the upvotes. All right, so we'll try doing that. Okay. All right, so this is known as .score. All right, so this is so this will pull out. So we'll try extracting out .score. Okay, and then from there, let's pull out the text. All right, so this is the score. These are the scores that it sees right now. So if I reload, so it's pretty, yeah, it seems right. So for whatever reason, it shows up multiple times. So 67 point, it looks like it updated to 67.2, 41.3, 199K, 21. So all of my numbers seem to be like 0.1 behind, but this is kind of what it's seeing right now. 21.4, 14.3, 17.5. So this is what it's getting. And for whatever reason, the information is just being tripled in the information there, but it's pulling all the it's pulling the text out. All right, can you guys see that? What's happening here? Okay, and again, this is just using the selector gadget. You kind of highlight, what it is that you want to pull. So if here, let's say I want to pull out the title. So we'll get so you kind of have to so I want these things in green. I don't want everything that's showing up in yellow. So I'm going to undo that. So this looks like what I want. .title. Let's go ahead and do that. Let's try that. The pipe is Control-Shift-M. Let's try putting in the title and let's see what we get. Okay, so it looks like it's pulling it out, right? So here it says, okay, so there's pulling a few more things, but it's extracting stuff from the site. So it says, police find and arrest spectator who caused mass Tour de France crash. MMA fighter Joe Schilling knocks out man. And it looks like we've got, again, for whatever reason, it's duplicating the text, but we're able to extract out this stuff, right? The dog on the left is award-winning show dog, Arnie, AKC French Bulldog, Catholic Church, Wojnarowski, there's no structural damage, et cetera, et cetera. So it's pulling the text out of the website. Okay. So that's basically how we're using Selector Gadget in conjunction with rvest, and it's as we can see, it's pulling live from whatever, whatever's showing up on the website right now at this moment. So in this case, once you have the text, then you can apply something like a regular expression, which we'll cover later, which will extract, say, digits out of the thing. So 9324, this is 1326, 636. This is kind of information that we might want to extract, and we can say, I only want to pull out things that look like digits, and we can pull those things out. Okay, so it's a very useful feature, I believe, useful set of functions in R. Okay, if you just go to regular Reddit, it's a little bit tougher. So if you just go to regular Reddit has infinite scroll, and this seemed to have worked. But so here, if I wanted to try to get the titles of this, and I run Selector Gadget, and I say, I want to get these titles. Maybe this works. Okay. When I tried it earlier, okay, so see this incomprehensible gobbledygook here. Okay, that is that's when I did it earlier, I got something similar, maybe a little bit different. Okay, as far as the name associated with the nodes. Okay, and it worked. It did pull out the it did pull out those titles, right? What's your strongest addiction? Police find and arrest spectator who caused Tour de France crash and things like that. So it looks like things have already updated since I've ran this this thing, but it's pulling out a lot of this text. But again, this thing looks, this is probably generated by JavaScript, not generated by a human. And so this is likely to change at some point in the future, and it might not work. So this is where rvest doesn't exactly work its best. Okay. So again, with say old Reddit, the tags are a little bit easier to read. Title that may blank. Those are those seem to work a little bit better. There's other functions out there that will do web scraping. So there's something called Selenium. There's that's like a little browser, and that works well with these pages that are generated via JavaScript, the ones that have infinite scroll and stuff. It's a powerful tool. Has a steeper learning curve, but at least I will tell you that this exists, and if it's something that you're interested in, you can take the time to kind of learn it on your own. Things in Python also work well. So there's Scrapies and Python Selenium, and also Python Beautiful Soup. Beautiful Soup is probably the easiest one to learn, but also probably the most limited. And then Scrapie and Selenium are more powerful. All right. So how do you know which websites are JavaScript generated? It's a little bit harder to know. But basically anything that's like super flashy and fancy, like as you're scrolling, if the content is like changing dynamically as you're scrolling, it's probably a JavaScript generated site, right? So like, every time I go to the Apple website and you look at stuff, okay, maybe not this, but right, like if you, as you're like scrolling down, it's like doing all kinds of stuff, probably powered by JavaScript. I'm not quite sure. Right, it's like stuff is like popping in and out of display. Who knows? It's possible that it's just done with HTML, but right, there's a lot of sites that like as you're scrolling, the content seems to be dynamically changing. That's most likely powered by a JavaScript thing, okay? Versus something where it's a little bit more static. So I have a little bit of a demo here doing with rvest. I did a little bit already, but let me go ahead and just kind of wipe this out and show you some stuff. So here I'm going to load up rvest. I'm going to load up stringer, and then we're going to the page I'm going to scrape is going to be this page. We're going to look at the Lego Movie webpage on IMDb. Okay, so this is the Lego Movie webpage, and we're going to try to just get some information here. So first thing, let's say I want to extract out the rating, the movie rating, 7.7. Okay, so I'm going to click Selector Gadget. All right, and then I'm going to hover over this number 7.7. This is the thing I want. Okay, and so it says the associated tag. I'm looking around, and it doesn't look like anything else got highlighted. And here it says only 2 things are highlighted, and I don't see where the second thing is. So that's good enough for me. Okay, I'm going to go ahead and just select this and use that as the tag I'm going to extract. Okay, FHMJQK, right? So anyway, that goes inside of here, right? So I'm going to start off by giving it the web address. I'm going to say read HTML from this web address, and it goes and it does that. And you can see, the way it stores is it's a list of 2. And if you say, what is Lego Movie, it says, it's an HTML document with, all kinds of stuff. Okay, so from there, from Lego Movie, I'm going to pipe it into rvest's function that says, extract out the HTML nodes. Which HTML nodes that we want to extract out? We want to extract out just this one. Okay, so let me just show you what happens if I just run this bit of text. Okay, so if I run this, then it pulls out the 2 kind of nodes. It says the XML node set that has that value 7.7 in it. Okay, 7.7 here. So from there, I want to extract out the text, and then I'm going to convert this into a number. So we're going to say pull out the text and then turn into a numeric thing. Okay, and then so now rating is this value 7.7. And again, for whatever reason, it shows up twice. And so, I probably have to do a little bit of a cleanup a little bit later, but I'm able to extract out that bit of information from the web page. Okay. All right. Let's say I want to get the cast information. I want to see who are the actors in the Lego Movie. All right. So again, using Selector Gadget, I'm going to come over here and I want to get just the actor names. Okay, so I'm going to click Chris Pratt here, and it looks like it highlights everything I want and nothing I don't want. All right, so that's actually good. We got pretty lucky, and it says the tag that we're going to use is this thing, EYQFNV. Okay, so it's a little bit of nonsense. It's hard to kind of understand, but here we'll go ahead and do that. So again, taking Lego Movie, I'm going to extract out the nodes that have this tag, and we're going to extract out the text. Okay. So I'll go ahead and do that. And here are the actor names. Okay, the names of the cast. We've got Chris Pratt, Will Ferrell, Elizabeth Banks, Will Arnett, Craig Berry, Alison Brie, etc., 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 and they show up right here. Okay. Sometimes there's white space. In this case, there isn't, but I had run string trim. Sometimes there's leading and trailing white space, and that will do that. Here, there's none, so it doesn't make a difference. But here now I have the list of cast members that works there. Okay, you can use rvest to extract out even longer things of text. So here I've got a user review. We will extract out this user review, all right? And this one was a little bit of a struggle to get. So if I click this, all right, this shows up in green. That's what I want, but then it also highlights a whole bunch of other stuff in yellow, right? It says 948 elements are going to get extracted. So I don't want that. So I'm going to just click something I don't want. I don't want this stuff. Okay. Let's see. Is there anything else? So just clicking something else to kind of say I don't want that thing, reduced it down to 6. I actually don't want this thing either, this storyline. So we'll go ahead and do that. And maybe I don't want this bar here. Okay. So anyway, now it's just this one thing, okay, that we're going to extract out. And I can copy this. And this is the tag is this very long thing. IPC overflow text list card. I don't know what this is, but that's the tag that got associated with it. And so we'll go ahead and pull that out. And if we read the review, this is the text. It says, if you watch the trailer and you think it's just going to be a fun stop motion animated movie, you were wrong. Okay, so anyway, this is beyond fun. Anyway, it's a great movie, 9 out of 10. And there's the text that we get. Okay. All right. So far, so good as far as using rvest. Okay. So this is the coolest part of rvest is you can create kind of this automated browser where you can say, you know what? Let's start at the Lego movie page. And what I want to do is I want to go to each of these actors. So we're going to start off with Chris Pratt. Let's click this character. And that will take me to Chris Pratt's webpage. And let's go down to his filmography. And I want to get the names of the projects that he's working on. So Cowboy Ninja Viking. I have no idea what that movie is about, but that sounds like Chris Pratt. Guardians of the Galaxy Volume 3, the Guardians of the Galaxy Holiday Special, the Terminal List, Jurassic World Domination, Thor, Love and Thunder, the Tomorrow War, Onward, Magic Gems, etc., etc., etc. So let's go ahead and extract this. So what we want to do is once we get to Chris Pratt's webpage, I'm going to use Selector Gadget and let's say, you know, I want to get the names of these projects that he's working on. Okay. So when I click this, it says 849 things. Okay, I don't want any of this stuff. Okay, now if I click this over here, now it says only 2 things. So I do want this. I don't want that. Let's see. I don't think I want these things. All right, so, you know, kind of just playing around with like clicking things I do want and don't want. I end up with this. I'm going to take out all the nodes that are highlighted with the tags B and A. Okay, BA. So from there, what I'm going to do is I'm going to tell rvest, you know, create a session, not a web page, but a session. A session says it's like you're opening a browser and you're starting on this web page. And now we're going to go to other websites. So I'm going to start a session. Okay, we're going to call our session S. All right, so here's my session. And from that session, we're going to follow the link that's titled Chris Pratt. Okay, we're going to say, follow this link, and that's going to take us to this webpage, right? So, you know, we started off on the Lego movie webpage. We start a session, we're going to follow the link that says Chris Pratt. That takes me to Chris Pratt's webpage. That takes me here. We're going to read in the HTML, and from there, we're going to extract all of the nodes that have BA, right? So we're going to read the HTML. That's going to be Chris Pratt's page. And from there, we're going to extract out all of the nodes that have BA. And let's pull out the top 15 projects there, okay? And so when we do that, it follows the link. And indeed, it extracts out the name top 15 projects that he's working on. Cowboy, Ninja Viking, Guardians of the Galaxy Volume 3, et cetera, et cetera, et cetera, right? So it's following that web page, going over here and extracting out everything that has those tags, okay? Let's say we also want to pull out the year that these projects are expected to be released. Okay, so I'm going to come over here, 2023, and that seems to have worked, .year column. So sure, that works. And so we're going to go ahead and we'll do a Chris page, and we'll pull out year column, and we get those values. We get NA, we get 2023, 2022, et cetera, et cetera. And we go, NA, what's going on there? And indeed, this this first project, Cowboy Ninja Biking, which has been announced, has no target date here. So so it makes sense that this is a missing value. This hashtag filmography, you know, when I did it earlier, that was part of the when I did Selector Gadget and I did this, hashtag filmography came as part of this, but for whatever reason, it's not anymore. So I could also just do this, and that would also work, I think. So this is just text that I have from working on it earlier, and that's what happened. Okay, so let's say I want to do this, but for multiple actors. Okay, so I'm going to try this out, and we're going to go back to the Lego movie webpage. And so question says, can we list them and sort them by rating or sort by other than act? So you have to scrape the data first, right? So everything is showing up on this webpage, and you can't really manipulate the webpage, but you can extract information from the webpage. And once you have it in your computer, then you can manipulate it, then you can sort it, then you can do calculations and stuff with it. So you have to get it out of the webpage into some format that your computer can work. And once you have it on your computer, then you can work with it. You can sort and do things like that. So here I'm going to just say, you know what, let's go through this, and I'm going to just do the first 4. So we'll do Chris Pratt, Will Ferrell, Elizabeth Banks, Will Arnett, but you know, I could extend this to do like the first 10 or something. Okay. And what we're going to do is, you know, we have the list of, we've got cast here. Okay. So we have all of these actors listed, and we're going to say, you know what, just for these first 4 elements, go to, you know, follow the link that says this name. And then on that page, that's going to be our actor page. So follow the link for that actor name, read in the HTML. That will be our actor page. And then from the actor page, read in the movies, the top 10 movies that they're working on. From the actor page, also read in the dates, and we'll store that. And then I'm going to store this all into a list. Okay. And so, so we're going to repeat that, and then we're going to create kind of into the actor name. We're going to create a data frame where the name is the name, the film is the movies, and the years is the years, right? So question, is there a limit to how many sessions we can have and run in case we're blocked? So yeah, so this is a thing. When you run these automated browser sessions, you know, a lot of websites don't like it when you keep hitting all of these and you try to extract a ton of data because they think, oh, you know what, you're some kind of bot. You're a bot. You're hitting us up, and you're trying to spam our website and things like that. And so if they notice strange activity, they might block your IP address. Okay, with good reason. So there's just some basic manners that you should follow, and that's like, don't hit the website, you know, a bajillion times within a short amount of time frame. When you're testing things out, you know, just test like, you know, 3 or 4 at a time, right? If you do like all 100 or something, you're probably going to trigger something on their end, right? If they have some kind of something that says, you know, to prevent this. So we're going to just go ahead and create this, run this loop, which will go through the first 4 actors. For each actor, it's going to follow the link to their webpage, pull out the movie names, pull out the years, and then it's going to combine them all together into a data frame. Does that kind of make sense, what I'm doing here? So we're going to run through this, and this again is an automated browser. So I'm going to create an empty list here, and then we're going to do this. So you can see, all right, it's following this first person, then this person, and then it's done. Okay. And so now this list, it's a list of 4 elements. We've got Chris Pratt, we've got Will Ferrell, we've got Elizabeth Banks, we've got Will Arnett. And then what I'm going to do now is I'm going to kind of just combine them all into one list. And I'm just going to take the rows from one element of the list and bind them in. Okay. So if I do that, now I've got this big data frame with 40 rows with 10 things from each actor. Okay. And yeah, so if you wanted to get movie ratings, you'd have to follow each of these pages to get kind of the rating associated with that thing. And yeah, it gets troublesome, but anyway, this is I think this is pretty neat as far as conducting doing some web scraping and being able to tell R to go out to the internet and pull information from there and get it into a form that you can work with. All right, any questions? So this percent greater than percent is known as the pipe. And basically it takes whatever's in front of the pipe and it puts it into the next function in order to kind of work with it, right? So a lot of times in R, you can write a function and then you want the result of that and you put that inside another function. So you have all of these kind of nested functions. You have something in the inside and then you work your way outwards. And basically the pipe does that, but you don't have to kind of nest things inside of each other. So it just takes the output of one function and pipes it in as the input for the next function. Okay, so this stuff should be on CCLE. You should have the rvest demo imdb.r file, and that's the script that I used here. Okay, and so I think, well, not I think, in your next homework 3, you'll be doing some stuff with rvest, and I think this will serve as a good starting point. For homework 3. Okay, we're going to continue on here. Excuse me, let me just get a sip of water here. Let me just. All right, let's continue on here, and I want to talk a little bit about the tidyverse, and a lot of the stuff I'm going to talk about today comes from this textbook R for Data Science, and it's free to read. You just go to the site, and if you're okay reading from the browser, it's all there. Okay. The tidyverse labels itself as an opinionated collection of R packages designed for data science, and they all kind of share this underlying design philosophy, grammar, and data structures. Depending on who you had as an instructor for Stats 20, you may have experience with the tidyverse, you may not have had experience with the tidyverse. Did anyone work with tidyr prior to this class?
A little bit, like, yeah.
Stats 20 or?
Yes, that's 20. Like, professor taught a little bit, like, but like just basic introduction.
Did they talk about pivot long and pivot wide?
Kind of, like they just mention it, and said like if you want to learn that, just, like they gave some like reference and say if you want to do that, like learn by yourself. But
okay, all right. Then, well, I will tell you about pivot long and pivot wide rather than say learn it on your own. So, okay, so that makes me feel better about this lesson not being total repeat material. So anyway, there's a whole bunch of packages. These are the core packages with the tidyverse. You've got ggplot too. I think you guys are familiar with that. And we'll cover a little bit more. Excuse me. We've got tibbles, tidyr, dplyr, readr, per, stringer, and forecast. And as far as this class goes, we'll look at tidyr today, and then we'll later on look at, we've already seen readr. We'll look at dplyr, we'll also look at stringer, and maybe we'll have time for a bit of ggplot as well. Okay, so Tibbles is basically like a data frame. Okay, so Tibbles, they are data frames, but they modify some behaviors to kind of make our life a little bit easier. So R is an old language. It's been around for a while, and things that were useful maybe 10 or 20 years ago now kind of get in your way, right? And it's kind of hard to change base R without breaking a whole bunch of existing code. So a lot of kind of innovation these days happens in packages, and the Tibble provides kind of these what we call opinionated data frames, which makes working in the tidyverse easier. And so so here is a data frame or a Tibble that we're going to create. It's got columns A, B, C, D, and E, and we're going to take basically 1,000 values, 1 10 to the third, and we're going to kind of multiply, add some random amount of time to now. We're going to take today, this will be a date time thing, some values and things like that. So anyway, when you do this, when you print a Tibble, this is how it looks. Okay, it there's an awareness of how wide your screen is, and I think I've set up in, you know, as far as creating stuff in the slides, I said, you know, I only want my output to be a certain number of column widths wide, right? So there's an awareness of how wide the contents of the screen is. Let me find where we are. Okay, so if I were to, oh, darn it. All right, so here there's an awareness of how wide my screen is. And so here it can fit A, B, C, D, E, and then it only prints out the first 10 rows. Now, if I were to change the width of my screen here, and I say print X, okay, here it only prints out kind of the first 2 columns because that's all it can fit, right? And it doesn't print out the other columns because they don't fit. And it says, you know, with 990 more rows and 3 more variables and things like that. Okay, when I widen my screen, it says, oh, you know, I can fit all of this, then it does. And that's basically what we've got going on here. Okay, there's an awareness of how many columns can fit the screen, and by default it only shows the first 10 rows, versus just kind of a traditional data frame. Let's see, print as data frame. Here it tries to print, you know, we've probably had this experience where you print this and then it just kind of dumps a whole bunch of stuff out onto the screen, and it just clears out the all of this stuff, and you're like, oh wait, I didn't actually want all of that stuff to appear, right? So so that could happen. You know, when you subset a Tibble, it works a tiny bit differently than when you subset a data frame. So when you subset a data frame using a single square bracket, sometimes if you extract out only one column, it will simplify just to a vector. With a Tibble, when you subset with single square brackets, it's always going to return a Tibble. So here, if you say, you know, I only want the first column, it's going to give you a Tibble with just one column in it. If you want to reduce down to a vector, which is what happens with the data frame, you can use this option drop equals true, and it will simplify down to a vector. So this is, you know, with a data frame, if you just say I only want the first column, it simplifies down to a vector. You know, with Tibbles, if you use double square bracket or $X, then it will reduce down to a vector. But again, with single square brackets, it will always remain a Tibble, just for kind of consistency there. So to kind of create a tibble, you do it the same way you would create a data frame, except instead of data.frame, you use tibble, and you give it the names of your columns equal to, whatever vectors you have that will go in there, right? You can also take an existing data frame and put tibble around it, and that will make a tibble version of that data frame. Okay. You are also allowed to create a tibble row-wise, and you do that by calling a tibble tribble. a row-wise tibble is what this is, okay? And so with a row-wise tibble, you can say, I want to, if you're going to kind of enter your data manually, a lot of times it's easier for us to think about these things row-wise. And so you can say, here, this is going to be column A and this is going to be column B. You give it little tildes here to kind of indicate that this is column name, and then the values you enter row-wise. Question, is it common to keep something as a tibble after subsetting? I guess it depends on what you're trying to accomplish, but the design philosophy of the tibble is that single square brackets will not change the nature of the product. That when you use a single square bracket, it will, because what you're using with the tibble, because you're using a single square bracket with the tibble, it should remain a tibble. Whether you're getting back one row or one column or one value, don't simplify it down to a single atomic vector or something like that, but just keep it a tibble. And I think that's a fine design philosophy. Just because sometimes you're dealing with like functions and you don't quite know what your output is. But if you can always expect that your output is going to be a tibble and not necessarily a vector, you can design functions around that rather than trying to have to run extra tests. Like, is the result that I got a vector? And if so, then we got to kind of change my behavior. Versus if you always know it's going to be a tibble, you can kind of maintain a certain amount of behavior. And so, so here's creating a row-wise tibble, and now the data is in here row-wise. Okay, so that's it for tibble creation, and the rest of today's lecture is going to be about pivoting data, which is, I think, an important concept, especially when you're dealing with values and you're reading in data from different sources. They might be in some kind of structure or format that is not conducive to the analysis that you are trying to do, right? And so, as far as our tables go, the tidy data sets, we say, every column is its own variable. So each variable gets its own column, and each column only has one variable. Every row is its own observation. And again, you only have one observation in a row, and one row will contain only one observation. And every cell is going to be a single value. So how does this work? So this is an example of tidy data. So here's some information about tropical storms. And we have, I guess, Storm Alberto with wind speed 110, pressure 1007. I don't know how pressure is measured, and this was the date of the storm, right? And we have these different storms, and this is kind of the information surrounding that, okay? And so this would be tidy data. Each variable, the storm name, the wind speed, the air pressure, and the date, each of those have their own columns, and that's that, okay? Here is a example of data that is not tidy. This is the number of cases, I think, of some disease, and maybe tuberculosis in different countries. We got France, Germany is DE, Deutschland, and US for United States. And these different years, 2011, 2012, and 2013. And apparently in France in the year 2011, there were 7,000 cases. In Germany, there were 5,800. And in the US, there were 15,000 cases of whatever disease we're tracking here. And so if we think about what are the variables, we have country, we have year, and the data is the number of cases. So we have, the country, the year, and the count. Those are our variables, but they are not stored in columns. They are, the countries in this column. The year is spread as column headings, and then the count is kind of spread out around here. So that's not tidy data. And then here's another example, and we could argue that this is tidy, but in another case, someone could argue that it's not. Okay, so we have city, New York, London, Beijing. We've got small particles and large particles. We got large, small, large, small, large, small, and then the amount. And so if we think about what are our variables, one could argue that our variables are, we have the city with the amount of large particles and the amount of small particles, and they're kind of stored in this strange form where it's like every other row is a large particle, every other row is a small particle, and we basically have two different variables, and they're stored in one column, and so that's going to make our analysis kind of hard. So we want to be able to have a way to kind of deal with this kind of data and this kind of data and turn it into, tidy data. So these are like little mini data sets, and you can read them in from GitHub. These data sets are available here. I'm just using read_CSV to get them in. All right, so one reason why we like tidy data is basically vectorized operations work really well. Yeah, I forgot. I've only given you one view quiz answer so far. All right, let me go ahead and give you your second view quiz answer. Second view quiz answer for today is the letter C. C as in cat. C as in cat is your second view quiz answer. C as in cat. Okay, so our vectorized operations work with tidy data. So here's my table of storms, and we could say, what's the ratio between the air pressure and the wind speed? And I can just do pressure divided by wind speed, and we do 1007 divided by 110, and we get 9.15. Okay, and then over here we got 1009 divided by 45, and we get 22.4. Okay, and we can do this so on and so forth for and so this is done vectorized, and we can get kind of the ratio for each value here. So that's why, one of the reasons why we like tidy data. Okay, all right, but let's take a look at this. Here is our cases data, right? We've got the country, we've got the year, and we got the number of cases that happen in that country in that year. And we say, well, you know what? Can I make this tidy, right? If I want each column to be a variable and each row to be an observation, can I do this? And so if I do this, what would the dimensions of the resulting data be? So here my variables are country, year, and count. So how many observations do I have? How many columns do I have? If you think you know the answer, go ahead and enter it in the chat for the dimensions of the resulting tidy data. Okay, so I see part of an answer. So we've got nine rows, and we'll have 3 columns, 9 by 3, exactly. Okay, so this is what it would be if we turned it into tidy data. We would have 1 row for France in the year 2011. We'd have 7,000 cases. Germany in the year 2011, 5,800 cases. US 2011, 15,000 cases, and so on and so forth. And the resulting data would have 9 rows and 3 columns. Does that make sense? As far as going from this data and turning it into this. Okay. So this operation where we are taking our data and we're basically pivoting, this is what we call pivoting our data. The result is this operation is called pivot longer because we're basically taking the data that's spread across multiple columns and we're gonna combine them all into one column that ends up being longer. So we say this is pivot longer. Okay, so the desired result, we're going to use pivot longer. This used to be called gather. Older versions of tidyr called this gather, but this is going to be called pivot longer because we're taking values that are spread out across 3 columns and we're combining them into one column, and the result is going to be, one column that's a lot longer. Okay, so the way we're going to do this is we're going to say gather the information that's currently in the columns 2011, 2012, and 2013. The column titles are, column names are 2011 through 2013. And when you do that, the names of the columns, okay, the names of the columns end up in their own column. And so what should we call that? We're going to call that the year, okay? So we're going to say, we're going to call that year. And then the values that we gathered, they end up in another column. What should we call that column? That column we're just going to call, I guess we called it N over here. Over here we called it cases. Okay, and so so this is what we have. The years, the values 2011, 2012, and 2013 end up in the column year, and then the number of cases end up in this column cases. Here it's sorted a little bit differently. It's sorted by country first, and then year. But we have our data 9 by 3. Okay, so the arguments are this. The columns are the names of the columns that we want pivoted. Okay, and the names 2 is just a character string, and the values 2 is again is a character string. And we're going to take the values and they end up in that column here. Okay, so the names are arbitrary. You could call it when it happened and how many, and it could do that. There's nothing inherent about the names years and cases. It can just be whatever you want. Probably year and cases are good names, but again, to just kind of illustrate that you can really put in whatever you want as far as names too and column values too. It'll work. Okay, so here's a question. What would happen if I only pivot the columns 2012 and 2013? 2012 and 2013. How many rows would I end up having? Okay, so we'd end up having 6 rows. What would happen to the values here? This column 2011, 7,000, 5,800, and 15,000. What would happen there? Okay, what happens is they get duplicated. Okay, so any column that you don't pivot just gets copied. Okay, so just like the country name, like it made sense for countries, France, Germany, US, it made sense for those things to get copied multiple times. And basically anything you don't pivot will just get duplicated. So France, the country names get duplicated. And then this thing, I mean, tidyr has no idea what this means. It doesn't know that this is like another piece of information. So it doesn't omit it, it just keeps it and it just duplicates it, okay? Whereas the columns that we did pivot, the 2012 and the 2013, those, again, they get combined into one column and those get pivoted longer. And we end up getting this 6 by 4 tibble as a result. Okay, so the columns that are not pivoted are duplicated for the new rows that get created. All right, does that kind of make sense? What's happening there? There, I hope so. What happens if I include country in the columns to pivot? So if I say pivot all the columns from country to 2013. How many rows will I have? How many columns will I have? Okay, I'm going to end up with 12 rows and 2 columns. Oh, wait. Okay, first it tells me I can't do that because country is a character and 2011 is type double. Okay, so, but then if I say, all right, turn everything into character, then we end up getting 12 rows and 2 columns. And basically everything, all of these values, because here I'm pivoting all 4 columns, all 4 columns end up into one column. They get pivoted into one column. France, 7,006, and then all of the column headings get pivoted into one column as well. Okay, so all of the column headings get pivoted into one column, and all of the values here get pivoted into one column. So we end up getting a 12 by 2. Okay, at first it complains and it says you can't combine the characters and the doubles. So I said, you know what, I'm going to just force everything to be a character, and then and then we can do it, and then everything's a character and it combines it all. And that's what we end up getting. I hope that makes sense as far as what pivoting longer does. Okay, let's take a look at the other table. We've got this pollution table. And we said, you know what, we've got 3 variables: the city, the amount of large particles, and the amount of small particles, right? City, large particle amount, small particle amount. So the resulting data will end up being 3 by 3, okay? We're gonna have New York, large 23, small 14. London, large 22, small 16. Beijing, large 121, small 56, okay? So if we do this, we're gonna get this. This operation, we're basically taking the values in one column and we're gonna pivot them to be a wider set of values, right? We're spreading them out. We call this pivot wider because we're going from one column to basically 2 columns. Then values inside this column become values in 2 columns. And we're going to use, as far as column headings, we're going to use kind of these key values. The large, small will become column headings. So, so here we're going to call this pivot wider. We're going to do pivot wider. We're going to take our pollution table. We're going to take the names, the column heading names are going to be in this column size. And then the values are going to come from this column that says amount. And values come from amount. And it does this. All right, so that's pivot wider. Okay, so again, value names from is the column that has the names that will become column headings. Values is the name of the column that has the values. And that's pivot wider. Okay, so pivot wider is sensitive to spelling differences. So here, what's going to happen here? All right, so notice I have New York City, New York written as New York here, and NYC there. So I've changed the way we spell New York from New York to NYC. So here I'm going to do pivot wider on this data. What will the resulting data look like? How many rows will I have? How many columns will I have? What do you guys think? Okay. So when everything was spelled consistently, I ended up with 3 rows and 3 columns. So in this case, I have 4 unique values for city. I have NYC, I have New York, I have London, I have Beijing. So each unique value in city is going to get its own row. NYC, New York, London, Beijing, okay? And then I have 2 unique values for inside the column size. So those become column headings. I got large and small, right? And so what ends up happening is I get populated with NAs for things that don't line up, right? Do I have an NYC small value? I don't, right? I don't have a small value going for NYC. So I get an NA. Do I have a New York large value? I don't. So I get an NA there. So that's what ends up happening. Okay, so I end up getting 4 rows and 3 columns. That's what we have. Okay. Here, instead of NAs, if you want to have a fill value and you want to just say 0 instead of NAs, you can do that. You can do values underscore fill, and you can set that and say, you know, instead of NAs, I want zeros, and that would work as well. Okay, but by default, it would say, you know, you don't have values, we're going to put in NA. Okay, so here I'm going to fix it back. So we get New York spelled correctly. So we have 3 unique city names. So our resulting thing will have three rows. But now, as far as size goes, I've got all caps large, and then lowercase large, and then lowercase small. So now, this is a unique way of spelling large for size. So it's going to get its own column. So with this data, the resulting data, I've got 3 rows. I've got New York, London, Beijing, 3 unique values for city. But then as far as when I pivot wider, this data, the values here in amount are going to go across 3 columns. We're going to have a column for lowercase large, a column for all caps large, and a column for small. So this is what we end up having. Okay, so we end up having a column for all caps large, small, and large, and we get NAs for the values that don't exist. So when you're doing pivot wider, you do want to make sure you probably want to do a little bit of cleanup to make sure that everything is spelled consistently down your columns. Okay, otherwise it's gonna get each of these things are gonna get its own unique values or unique rows or unique columns, which is not what we want. Okay. Does that feel good? All right, let me go ahead and give you your last view quiz answer. Last view quiz answer for today is the letter E. E as in elephant. E as in elephant is your last view quiz answer. So pivot longer and pivot wider, those are kind of inverse operations of each other. So here I've got the pollution table, and when I pivot wider, I end up getting this. So I go from a 6x3 table, I pivot wider and I get a 3x3 table. Basically taking the values in this column and widening them across multiple columns. But then I could take the resulting wide table and I could pivot them longer, and I can convert it back to basically what I started with, right? So going from 1 column down across to 2 columns, this is pivot wider. And I could say, you know, I want those values across 2 columns and I want to put them back into 1 column, and that would be pivot longer. All right, so pivot wider and pivot longer, these are inverse operations. And depending on your situation, you know, you might want to be able to do a difference. You might want to be able to calculate the ratio between large and small values. And in other cases, you might actually want the data in this form for whatever reason. And so, so you could do something like that too. So depending on how you're working, you can pivot wide, pivot longer. They're kind of inverse operations of each other, right? Same thing with our cases table. Here we pivoted them longer to form our data like this. But if someone says, you know what, I don't just want them in this form, I want to actually be able to kind of calculate, you know, what was the increase from 2011 to 2012 or something like that, then in that case, it might be useful to have it in this wider format. So if we do pivot wider, we can take the long data and we can pivot them wider back into this form as well. So that's a possibility. Okay. There's another operation set called rectangling, but I'm not going to get into it, but you can read about it. But here we'll just, I'm just going to end up pivoting, and we'll end our lecture a little bit early today. Let you guys go a little bit early, and that will be it. So, and that's it. It's kind of strange. We only get 1 lecture this week, and same thing next week. So have a good weekend. I hope the kind of the tips and advice I gave regarding homework 2 is helpful. So, I'll have office hours, I guess from now until, I guess I'll start office hours if you guys have questions. And then I have office hours tomorrow morning and as well as Saturday morning. So if you have questions, don't hesitate to ask. But I'll just let you guys go early, and if not, have a good weekend, and we'll see you guys. We got a holiday on Monday, so I'll see you guys next Wednesday. I'll see you in a week from today. So that's all. All right. Have a good night.